Okay, I will share my screen. Okay. Could you see my screen?
Yes,
You
sir.
see my writing? You can see my writing, no? Okay. So we are still in logic circuits. Okay. We are still in logic circuit. Okay. So to implement these logic circuits, we are usually used logic gates. Okay. Logic gates. Okay. So you already know what are the basic logic gates and the function of those logic gates. Okay. So we already discussed that when we are talking about a circuit, okay, when we are talking about electronic circuits, basically we have to do two things. Okay. One is design. One is designing circuits. Okay, designing circuits. Okay. Another one is analyzing the circuits. Okay, so we have already discussed these things. Okay, so designing means synthesis. Also, we are calling this synthesizing. Okay, so both designing and analyzing circuits. Okay, so you already know that these logic gates. Okay, these logic gates, the input-output relationship. Okay, the IO relationship we can get through a Boolean expression. No? Boolean expression. Okay, so you already know this. Okay? The input-output relationship of this gate circuits. Okay, of these circuits, we can represent using a Boolean expression. Okay, for designing and analyzing, we need to simplify. Okay, simplify this Boolean expression. Okay, we need to simplify this Boolean expression. So that one also you have learned. We have discussed these things. Okay, so simplifying Boolean expression is very important actually. Okay, because the simplification we need for designing and also for analyzing. Okay, so so we have already discussed three methods. Okay, we have discussed three methods of simplifying Boolean expression. Okay, the first one is using Boolean algebra. Okay, using Boolean algebra, you can simplify this Boolean expression, or you can use K-maps. Okay, and you have algorithms. Okay, that is we called Pin Mcclusckey algorithms. Okay, Pin Mcclusckey tabular method. Okay, tabular method. Let's say QM methods, QM tabular methods. Okay. Okay. So we have three techniques to simplify this Boolean expression. Okay. Using Boolean algebra, using corner map, and using QM tabular method. Okay. So we have already discussed this Boolean algebra. Okay. To use the Boolean algebra to simplify a Boolean expression, you need to know the laws, and there are some theorems, De Morgan's theorems, and associative laws, distributive laws. Likewise, you have some laws and theorems, okay, to use the Boolean algebra to simplify a Boolean expression, you need to remember those laws and those theorems, okay, and also you have to know the right place those should be applied, no? Otherwise you can't do it, okay. So you should have some kind of mathematical knowledge, no, mathematical practice to go through this Boolean algebra techniques, okay. So it is not an easy one, okay. Maybe it is easy for one or two variables, okay. uh, uh, I already told you that when we are talking about variables, we are only talking about the inputs, okay, inputs of the circuits, okay. So if the inputs are very low, if you have 2 or 3 inputs, maybe this Boolean algebra method is okay, okay. Another thing is k-maps, okay. So if you have higher number of inputs, okay, higher number of inputs variable, okay, so you can use this k-maps, okay. So this k-maps also you have some kind of it, also some kind of algorithm, okay. But you have to look at that one, that is a graphical representation, actually. Graphical method to simplify a Boolean expression, okay. So that one is also not easy if the variables are too high. For example, maybe up to 5, 6, 7 variables, input variables, maybe this came up okay. Okay. But if you have more, maybe 10, 11 inputs variable, this K-map also is not easy. It also will be difficult. Okay. So this QM tabular method is good for, okay. So this is somewhat complex. Okay. This is somewhat complex, but it is good for good if you have much number of input variables, okay. And I have also told you one another advantage of this tabular method. So this is an algorithm, actually. This is an algorithm, so we can implement this in a computer, okay. So maybe using a MATLAB, or maybe using a Python, okay, or any other language, any other computer language, you can implement this in a in a computer, okay, so that you can easily use this, okay. So today we are going to learn about this QM tabular method, Queen Mcclusckey tabular method, okay. Before starting the algorithm, I want to tell you something, okay. So you know that Boolean expressions, no? So it will look like this, okay. It will look like this, maybe, okay. Yes. Body plus ACD, maybe like this, okay. This example, okay. So Boolean expression will look like this, no? Okay. So these are the variables, okay. These are the variables, okay. And so you know that when designing a logic circuit using a truth table, what is the method? Can someone told? Get 2 minutes and can someone explain it? What is the method? If you are using a truth table to design a logic circuit, what is the method? Okay, normally we draw the truth table first. Okay, we draw the truth table. Okay, for our purpose, okay. And we select the output that give ones, no, that gives ones. Can you remember? We select the outputs that gives 1. Then this ones we combine as a using we combine these ones using O function, not O function, using N function with these inputs, okay, with the inputs, and function with inputs, okay. Then all those uh, those terms we combine using OR function, no, OR gate, okay. So you will have, first you will have some product, okay. You will have some product like this, okay. You will have some products, okay. And then you have add them, okay. So this will be a sum of product, no, okay. So that will be a sum of product. For example, if you have F A B C plus A B C or something plus A bar B bar C bar, okay. So you can see that these are product, okay, and all product are summed together, added together. So this is product of sum, product of sums, okay. This is product of sum. And also we can see that some Boolean expression may be sum of product. That means you have some summation, okay, and those summation are multiplied, okay. So this is a sum of product, okay. This is a, sorry, I think I have mistake, no.
It's the opposite, no? The first one is only sum of product.
This is a product, sorry, this is a sum of product, okay. I'm sorry, thank you. This is a sum of product, okay. So this is sum of product, okay, and this is product of sums, okay. Thank you. Yeah, thank you. This is product of sum, okay, product of sum, okay. And sometime you will have this kind of expression also, because there are some gates and the output you will get using not gate, okay. So you will have this kind of one, okay. I will write it here, okay. So you will have this kind of one, okay. So at first you can't tell this is a sum of product or product of sum, but you can use De Morgan's theorems and try to resolve this, so that maybe you can express this as a sum of product or product of sum or both combination, okay. So what I want to tell you is that uh, almost all Boolean expression we can express as a sum of product or product of sum, okay, and combination of these two, okay. Is that clear? I hope it is clear for you, okay. Any almost any Boolean expression we can express as a sum of product, or maybe a product of sum, or maybe a combination of both sum of product and product of sum, okay. uh, so that is the basic idea you should have before we start this QM tabular method, okay. uh, so I think now we can go to our algorithms, okay. So we will go, okay. So this is, so we are going to learn clean Mcclusckey method, tabular method, tabular method, to simplifying Boolean expression. Okay, so in your reference book, you have this. I hope you can see the book, no? Okay, so this is your reference book, and you have Queen Mcclusckey tabular method. Okay, and you have the step here. Okay, you have the step here, and there is little difference when we apply this Mcclusckey method. There is little difference when we are dealing with product of sum and sum of product. Okay, actually that is the difference. Okay, so this will be the difference. Okay, so I think if you have draw the K maps for sum of product, not sum of product of sum, you already have know this. Okay, so once when we are using sum of product, okay, when we are writing the binary representation, we put ones for true value, okay, and zeros for complement. Okay, and I will explain this when we are doing the example. I will explain this. Okay, so you will get clear this is stuff. Okay, so don't worry if you can't understand this at this time. Okay, and if you have a product of sum, the reverse, we get the reverse. Okay, product of sum, we get the reverse. That means for true value, for example, if you have a b c like this, you will get 0. Okay, and you, if you have a bar c bar like this, you will get 1. You should get 1. Okay, so that is the thing you should keep remember. Okay, uh, but when we are doing the example, it will be clear. Okay, and here you have the steps. Okay, all the steps are there. Okay, so the first step is, okay, the first step is, if you are given a Boolean expression, it should be expanded. Okay, it should be expanded to a canonical form actually. Okay, so that is your first one. Okay, so if you are given a Boolean expression, first you have to expand it to a canonical form. Canonical, I can't remember the words. Okay, canonical form. Okay, that means all variable should be there in all terms. Okay, so you have to convert it to a canonical form. Okay, for example, so I think example is given. So this is already canonical form. Okay, so here, okay, so you can see that so if you are given this kind of Boolean expression, okay, this kind of Boolean expression, you can see that this is not in canonical form. No, this is not in canonical form. Okay, so you have to make this canonical. That is it mentioned as expand. Okay, that is it mentioned and expand. This one should be expanded means you should make the canonical form. Okay, so how we can make this to a canonical form? Can someone tell me? We have discussed this in our last mentoring session. Okay, can you remember uh, what law we should use? What identity we should use to do the expand? Can someone feedback, please? So what is the method to expand this expression or make this expression as a canonical? Yeah, yeah, we have to use that identity. Okay, so I got one answer. Okay, I think yeah, yeah. Thank you, Geeta. So you have to use that identity. Okay, you have to use this x plus x bar is equal to 1, this identity. Okay, for example, you can see that you have four variables. Okay, you have four variables a, b, c, d. Okay, and uh, very importantly, when you are writing, you have so normally uh, in the expression. Okay, in the expression, it should be given the least significant bit and most significant bit. Okay, so if you have four variables, four inputs a, b, c, d. Okay, so this will be your least significant bit, and this will be your most significant bit. Okay, and it should be given the least significant bit and most significant bit m, a, b, c, d, and you have to write all the terms with this manner. Okay, from most significant bit to least significant bit. That means a, b, c, d, a bar, b bar, d, a, not d, c, d, likewise. Okay, so you have to you have to write it in this way. Okay, otherwise you will get uh, uh, you may get a wrong answer. Okay, so you have to write this in a proper manner. Okay, from most significant bit to least significant bit. Okay, when you are doing the example, I think these things you will get more clear. Okay, okay, so now how we can convert this to a canonical form. Okay, so you can see that here you have only c. Okay, so d variable is not there, so you can multiply this a bar b c terms using d plus d bar. D plus d bar is equal to 1, so it will not affect, no? So you are going to multiply this term by 1, so you should get the same expression, no? Same term. Okay, so now when you are writing these terms, if you write this like this, a bar, so you can expand this. Okay, you can expand this. Okay, so when we are expanding, okay, so if you write this like this, a bar, b, c, d, so it will be wrong. Okay, so you have to write it from most significant to least significant bit respectively. So you have to write it b, c. That is what I told you. I think it is clear, no? A bar, b, d, sorry. Okay, if you write it a bar, b, d, c, it will be wrong. Okay, and you have to write it. If you write this when you are uh, expanding this, okay, I'm sorry, I make a mistake. Okay, if you are expanding this, if you write this as a bar, b, d, c, like this, okay, so you will get a incorrect answer sometime. Okay, so you have to write it this from most significant bit to least significant bit respectively, so that you have to write it as a bar, b, c, d. Okay, and these terms you can write it as a bar, b, c, d bar. Okay, in the same manner you can expand this one. Okay, to expand this one, you have to multiply this by c plus c bar, because c term is not there. Okay, so you will get a b bar dc. If you write this like a b bar dc, so you will get the wrong answer. So it is better to write in a proper way. Okay, that is A bar B bar C D plus, if you multiply it with this, you will get A bar B bar D C, sorry, DC bar. But if you write this in this way, it will be wrong. So you have to write it as C bar D. Okay, like this. Okay. So what is the to make this canonical? This term should be multiplied by what? Can someone answer? This term should be multiplied by what? Please give answer. Just you can put it in the chat box. Just type it and send me what. So we have multiplied this using C plus C bar because the C term is not there. Okay, and if you want to expand this term, okay, what is the coefficients we should multiply this? And someone feedback, please. Yeah, we have to. We have A, C, D here, and B is not there, no? So you have to multiply it by B plus B bar. Okay, and you have to write it in a most significant bit to least significant bit. So you can write it as A, B, C bar D plus A, B bar, C bar D. Okay, and you have expand this term also. And if you want to expand this term, what is the term you should multiply? Can another student answer?
A plus C bar.
Yeah, A plus B bar. Very good. Okay, so you have to multiply this by A plus A plus A bar. Okay, then you can expand this. Okay, and this is already expanded, no? So you no need to expand this one. You can put it as in that form. Okay, so this you will get A B C A B C bar D bar plus A bar B C bar D bar, and this term you will get A bar B C bar D. Okay, so before going to so this is the first step. When you are using the the QM method, this will be the first step. You have to expand the terms, okay, to the canonical form using x plus x bar is equal to 1 this side. Okay, so I think it is clear. Are you clear with this? So if you have any problem, please ask. Okay, so complete it just now. Okay, learn this method at this moment. Okay, if you have any doubts, you can please clear it here. Okay, so are you okay with this expanding method, this expanding? If anyone has a problem, you can ask, then I will explain it again. Okay, are you all clear with this? So I didn't get any feedback. That means I hope you all understood this very well. Okay. Um, so we can move to the next step. Okay. Uh, so you can see that so here we have a example. Okay. So this will be the example. Okay. And I will keep that example for you. Okay. To practice. And I will do another another problem to explain this step, other step. Okay. So we will move to our, so so let's say that we have this kind of expression. Okay. This kind of expression. A bar, B bar, C bar, D bar, plus. So I get this question from a past paper. Okay. C bar D. So this kind of question will come to your exam. Okay. I get this question from a past paper, maybe at the last year or earlier year. I can't remember the year. Okay. So you have A bar, B bar, C bar, D bar, A bar, B bar, C bar, D, plus A bar, B bar, C, D, plus A bar, B, C, D, plus A, B bar, C bar, D bar, plus A, B bar, C bar, D bar, plus A, B bar, C bar, D, A, B bar, C bar, D bar, A, B bar, C bar, D, plus A, B bar, C, D, plus A, B, C, D. So you can see that in this example, so this is our example one, okay? In this example, how many variables you have? How many input variables you have? Yeah, we have 4 variables, no? Okay, so if it is 4 variables, maybe K-map method is the most easiest one, okay? But I will get only 4 variables to give you the idea about this QM tabular method, okay? So that you can use it for any number of variables. If you are familiar with these steps, you will be able to do this any number of variables. So first we will consider an example only with 4 variables. Okay, only with 4 variables. Okay, so what is the first system? Okay, so you can see that we have 4 variables. Okay, so before going going to this before going for solving, you have to know these things. Okay, the first thing is you have 4 variables. Okay, and those variables are A, B, C, D. Okay, so you can see that every terms are A, B, C, D, A, B, C, D in manner. Okay, in that manner. So you can uh, you can uh, you can assume that this A will be the most significant bit, and this D will be the least significant bit. Okay, so that way you can assume this. Okay, you can note this. Okay, so that is that one you should know. Okay, and what is the first step? What is the first step? First step is expanding. No? Expanding. So we should expand this expression or not? Yeah, we no need to expand this expression, no? Because it is already expanded. Okay, it is already expanded form in canonical form. Okay, so in every terms, all variables are there. In this terms and this terms, all variables are there. Okay, so we no need to do the expanding. Okay, and we need to go to our first, the second step. Okay. Okay. So we will see the second step. Okay. So the second step is, okay, maybe I am taking some step. Okay, maybe those are not directly tally with the with this step in your uh, reference book. Okay, but don't worry. Okay, I will explain this, then you can understand those things also. Uh, Actually, maybe in one step, I will explain it as a two step. Okay, so that is the difference. Okay, so don't worry. Okay, so second step is we have to write the binary representation of these terms. Okay, as I can remember, these are called terms. Okay, these are called terms. These are called terms. Okay, so if you have time, uh, try to verify this. Okay, so these are called terms as I can remember. Okay, I'm not going to ask these terms in the exam, so you no need to worry. Okay, uh, so first we have to write the terms. Okay, okay, the binary representation of these terms. Okay, so you have A, B, C, D. Okay, so you have four variables. Okay, so if you write the binary representation, how can you write? Okay, so you can see that this is a sum of product. This is a sum of product. This time I said it correctly, no? This is a sum of product. Okay, is that wrong? No, no. This is a sum of product. These are product and you have a sum. Okay, so this is a sum of product. Okay, so I already told you that for sum of product, okay, if you have true value, you have to get a 1. If you have complement value for the variables, we are talking about the variables. Okay, if the variables has true value, you will get it as 1, and if the variable has complement value, bar value, you will get it as 0. Okay, so how can you write this first term? This first term. Okay, so I will say it is first term. Okay, so how can you write this first term? Please send me one answer, one or two answer. Yes, we have to write it as 0, 0, 0, 0. Okay, because all are complements, no? A bar, B bar, C bar, D bar. All are complement. Okay, so you have to use 0. Okay, so this is the binary representation of this terms. Okay, actually this is not the first terms. Okay, normally terms are numbered with the binary decimal value, as I can remember. Okay, I'm not sure actually. Okay, so 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 uh, so this is so you will have 0, 0, 0, 0. What is the binary value? Sorry, decimal value. That is 0. No? So this is the 0th terms. Okay, so this is the zeroth terms. Your first term is the zeroth terms. Okay, okay, and if you write the binary representation for this term, okay, you will have, I will write it to save the, so you can do this with me. Okay, I think you already have a paper and a pen, so you can do this with me. Okay, so this will be, and if I am doing any mistake, you can tell me. Okay, if I am doing any mistake, you can tell me. Please tell me. Sometime I will make mistake. Okay, I'm not good at these things. Okay, I can't focus this stuff very well. Okay, so if I am doing any mistake, you can tell me. Okay, actually that is why I want to do this uh, as a live. Okay, if I record this, I am making many mistakes and no one there to tell me the mistake. Okay, so that is why I took this session as a live online session. Okay, okay, so if I write these terms, it will be 0 0 0 1. Okay, so this will be your first terms. Okay, so this will be your first term. Okay, because this is the binary value is 1. For this terms, the binary value is 1, so it will be the term 1. Okay, and if you write this one, you will have 0 0 1 1. Okay, so it will be 3, no, 1 2 3, so it will be third terms. Okay, okay, and if you consider this term, it will be A bar B bar C D. That means 0 0 1 1. Okay, so this will be your, so we have already write that one, no? So we had to write this one, A bar B C D, A bar 0 B C D. Okay, I'm writing this one, A bar 0 1 1 1. Okay, so 0 1 1 1. Okay, so what is the value of this? 1 2 3, and another this is 4, no? This is 2 0, this is 2 1, this is 2 2, this is 2 3. Okay, so you have 3 4, that is 7, no? M7. So this will be your seventh terms. Okay, and if you write this one, you have A B bar 1 2 3 4 5 6 7. We have 1 2 3 4 5 6 7. Okay. Okay, then this times. Okay, so this is A B bar C bar D bar. Okay, so this is 1 0 0 0, no? 1 0 0 0. Okay, so this will be your 8, no? This is 8 8 mental. Okay, and what is this one? 0, sorry, 1 0 0 1. So it is 1 0 0 1. So it will be your sorry, 9, no? 9. Okay, and what is this one? 0, sorry, 1 0 1 1. 1 0 1 1. So you will have 3 and 1. So this is M11, no? Okay, and this will be your last term, that is A B C D, that is 1 1 1 1. Okay, so that is 15, no? M50, that is 1 1 1 1. Okay. So all you get this value. Can someone please confirm? All you get this one value. Okay, so what is the first step? Sorry, second step. We have to write the binary representation of all these terms. Okay, all these terms. Okay, binary representation of all these terms. Binary representation of this of all the terms. Okay, all the terms. So when you are writing the binary representation, you have to uh, uh, verify this is a sum of product or product of sum. So if the sum of if it is a sum of product, if the variables has true, you have to put one when you are when you are doing the binary representation. You have to put one, and if you have uh, the complement of a variable, you have to put it 0. Okay, and if you have a product of sum, you have to do this in other way around. Okay, so if you have a true value, if it is a product of sum, okay, if it is a product of sum, you have to put it, if the true variables are true, you have to put it 0, and if you have the variables are complement, you will have 1. Okay, so that is in case of product of sum. Okay, so this is a sum of product. Okay, so for complement value you will put 0, and the true value you will put 1. Okay, so did you all get this binary code? I think this is correct. Okay, because M0, 1, 3, 7, 8, 9, 11, 15. That was the main terms. Okay, so it should be correct. Okay, so have you complete up to this? Okay, are you clear with this step? Are you all clear with this step? If you have any concern or anything, you can feed me back. Okay. Are you clear with this step? Are you all clear with this step?
Yes, sir.
Okay, thank you. So we will move on. Okay, so this is our second step. Okay, what we have to do is that for all terms, we have this one also very easy. We just represent the terms in binary form. Okay, so we put the binary representation. Okay, now we go to the step 3. Okay, shall I do the step 3 here because I need this value to continue? Okay, maybe. So, okay. So now we are going to do the step 3. Okay, step 3. Step 3. In step 3, you need to make a table and you need to make a group. Okay, you need to make a group. Okay, group. Group. This group you need to make based on number of 1. Okay, you should group this based on number of ones. Okay, number of ones. Okay, to you need to group of based on number of ones. Okay, and the number of ones from minimum to my maximum. Okay, the number of ones. Okay, number of ones should be minimum to maximum. Okay, minimum to maximum. Okay, in this manner, you have to group these terms, okay? Maximum, okay? So I will explain this when we are doing this, you will be clear with this, okay? So we need to, so I will, so we need to prepare a table, okay? So I will put my table, okay? So in table, you should have the group, okay? You should have the group, okay? And you should have the binary representation, okay? And you should have the binary representation, okay? Representation, okay? So, so I told you that we need to group this based on number of ones, okay? So if you have same number of ones, okay, equal number of ones, you will put it in one group, okay? So you can see that here you have no number of ones, no? Number of ones are 0, okay? Number of ones, okay? Number of ones, 0. Here you have number of ones, 1. Here you have number of ones, 2. Here you have number of 1, 3. Here you have number of 1, again 1. Here you have number of ones, 2. Here you have number of 1, 3. Here you have number of 1, 4. Okay. So you should make the group based on number 1, based on numbers, the number of ones, okay, number of ones from minimum to maximum. Okay, so here you have the minimum number of ones, no? 0. There is no 0. So this will be your minimum number of ones. Okay, number of ones. So this will be your first group. Okay, and here you have 1 and 1. This one and this one you have only one ones. Okay, you have only one ones. Okay, so this will be your second group. So this will be your, so let's say that this is a 0th group and this will be your first group. Okay, and here you can see that here you have 2 number of ones, here you have 2 number of ones. Okay, and this will be your third group. Okay, sorry. Okay, yeah, that is okay. Okay, so this is, you have 2 number of 1, 2 number of 1. So this will be your third group. Sorry, first group, second group. No? This will be your second group. 0 group, first group, second group, and you here you have 3 number of ones. Okay, 3 number of ones. So this will be your third group, and here you have 4 number of ones. So this will be your fourth group. Are you clear with this? Please, if you have any problem, please ask. Okay, if you didn't understand this very well, please ask. Okay, so you have to understand the specific step, otherwise we can't go further. Okay, we can't move on. Okay, so you have to tell me if you have any problems. Okay, if you are not if you not fully understand this, you can ask me. Okay, so here we are trying to group this memterms. Okay, these memterms, okay, based on number of ones. Okay, based on number of 1, from minimum number of ones to the maximum number of ones. Okay, so we are going to group. Okay, so here you have 0, there is no 1. So this will be your first group. And here you have 1 and 1. Okay, only 1. Okay, number of ones is 1. Okay, so here it will be your second group. And here you have two ones, and here also you have 2 ones. So it will be your third group. And here you have third one, 3 number of ones. And here also you have 3 number of ones. Okay, 3 ones are there. Here also 3 ones. So that will be your next group. Okay, and here you have 4 ones, 1, 1, 1, 1. So that will be your fourth group. Okay, so I hope you clear it. Okay, so and if you need, I think you can write the mem terms also, the corresponding mem terms. Okay, so this is the mem terms, corresponding mem terms. Okay, so group 0, you have only this mem terms, no? That means M0. Okay, so the binary representation is 0, 0, 0, 0. Okay, and for the first group, okay, for the first group, you have this one, M1 and M8, M1 and M8, no? M1 and M8, correct? Yes, you have first group, M1 and M8. So what is the M1? M1 is 0, 0, 0, 1. M8 is 1, 0, 0, 0. Okay. And in the second group, what are the mem terms you should have? Please feedback someone. In the next group, what are the mem terms? So here number of 1 is 0. Here number of ones are 1. Okay. You have 1 here, only 1 here, 1 ones here. Okay. Here you should have 2 ones. No? In this group, you should have 2 ones. Okay. So what are the mem terms? Yeah, so this is M8. Thank you. Okay, this is M8. Okay, and what is the next group? You should have 2 ones, no? You should have 2 ones in this group. Okay. So here you have a group. Here you have a group. In this group, you should have 2 ones. So what are the mem terms? Can you tell me the mem terms value? It should be this one and this one, no? This one and this one. This one and this one. Correct. So what is the mem terms value? M3 and M9, no? Okay. Is that correct? So here you should have 2 ones. Okay. So this has 2 ones. Okay. This has 2 ones. And this has 2 ones. And this has 2 ones. That is M3 and M8. Okay. M3 and M8. M3 and M9. No? Sorry. M3 and M9. Yeah. M3 and M9. This one and this one. M3 and M9. Okay. So M3, you can write it as 0, 0, 1, 1. M9 is 1, 0, 0, 1. Okay. So this will be your second book. And the next book, you should have 3 number of ones. Okay. So 3 ones should be there. So what are the mentals? Please tell me, someone. M7 and M11. Yeah. Let's see. Okay. So here you have M7, 3 ones, and M11s, you have 3 ones. Yes, very good. It should be M3, M7 and M11, no? M7 and M11, yeah. M7 and M11. So M7 is 0, 1, 1, 1. M11 is 1, 0, 1, 1. Huh? Okay. So what is the other group? Repeat back. What is the other group? What is the other group? You should have 4 number of ones. 4 ones. So what are the mentums you will have? Can, yeah, very good. It should be M15, no? The 15 mentums. Okay, so it will be 1, 1, 1, 1. Okay, so you have completed the second step. So you have grouped this based on number of ones from minimum to the maximum. Here you have 0 number of ones. Here you have 1 number of ones. Okay. Okay. Here you have 0 number of ones. Here you have now 1 number of ones. Okay. And here you have 2 number of ones. Here you have 3 number of ones. Here you have 4 number of ones. Okay. So you should write it from minimum number of ones to maximum number of ones. Okay. So you have to. Okay. Okay. So if anyone has a problem with this system. Okay. Are you okay with this? With this step 3? So I think you okay. If you have any problem, please ask. Okay. Don't be silent. Please ask. Please resolve all your question here. Okay. Then you can save the time. Okay. You no need to go through this again. You can directly uh, do the example. Okay. By yourself. Okay. So I hope this one also clear for you. Okay. Now we should move to the step 3. Okay. Now we should move to the step 3. Okay. Not step 3, actually step 4. Okay. Here also you are grouping. Okay. Here also you are grouping. Okay. And here you have to do one thing. Okay. Here you have to do another thing. Okay. That is, I will explain. Okay. Okay. Need to look at this one, and so shall I write it here? Okay. I will write it here. The next one also I will write it here. Okay. I will just bring this. Okay. Because I need to see this. Okay, otherwise I can't go to the next step. Okay, so we will do the step 4. Okay, so we will do the step 4. Okay, and step 4 we are doing so in the third step we group, no, we group. Now in fourth step we are going to match the group. We are going to match the group. Okay, I will tell you how we are going to match. Okay, we are going to match the group. Okay, so when we are matching the group, always we should match one group with the next group. Okay, if I tell it generally, nth group with the n plus 1 group. Okay, so in this way you have to match. Okay, that means you have to match it, the 0 group with 1, the first group, the 1th group with 2, then second group with third group, third group with fourth group, likewise. Okay, n group with the n plus 1 group. Okay, in this manner you have to match. Okay, so how you are match? Okay, so for the matching also you are going to look at the ones. Okay, not 0. You are going to look at the ones only. Okay, so if you have, so when you are matching, okay, when you are matching, if you have only one change, only one bit change, we consider it as a match pair. Okay, so another point, if you have only one, that is very important. Okay, only one bit mismatch, so you will make a matched pair. Okay, you will make a matched pair. In that time also you are going to match. Okay, if you have 2 or 3 bit mismatch, you are not going to match this. Okay, so if you have only 1 bit mismatch, you are going to match the pair. Okay, so we will see what is the story. Okay, I take this. I'll take this one. Okay, okay, so I'm going to group. Okay, so I think now you have a general idea. Okay, so you are going to map the nth group with the n plus 1 group. Okay, and if uh, one binary representation, okay, and you are going to match this binary representation. Okay, so if you have only 1 bit change, you are going to match it. Okay, so that is the idea. Okay, so I will do this. Okay, so you can get the idea, I think. Okay, so again I will write group. Okay, and here I will write it as this part is not mandatory. Okay, if you can leave this part. Okay, and you can only see the binary representation. Okay, but I am actually familiar with this method. Okay, I also write the main terms. Okay, okay, so that is why I write the main terms. Okay, so here I will write it as matched pair. Okay, matched pair. Okay, matched pair and binary representation. Binary representation. Okay, binary representation. Now I'm going to map. Okay, So this is my first group, okay, zero group. So I have to map it with the one group, okay. So in one group you have two main terms, you have two chords, okay. So this should be try to match this one, and this should also be try to match with this one, okay. And you should check only once are change, we will match it as a match pair, okay, otherwise we are not, okay. So you can see that if you consider M0 and M1, so this is the first group one, zeroth group one, and this is the first group terms, okay. So you can see that this one same, this one same, this bit same, and this only this bit is change, okay. So you can put it as a one matched pair, okay. So here you have zero, the group zero, and the matched pair is M0 and M1, okay, M0 and M1, okay. And when you are writing the binary representation, so this all the equal bits you will put it as same, okay, but the other bits, this 0 and 1, okay, so it will be cancelled, okay. So you put just a space, okay, just put underscore, okay. So in this position you just put the underscore, okay. Are you clear? Are you clear this? Are you clear this? Yeah, okay. So we will go to the next one. And I am going to, so still I am in this group, okay. I am still matching the group 1, group 0 with the first group, okay. I'm still doing this, okay. I have matched one terms, and I have to match this one with this one, okay. So you have M0 with M8, okay, and you can see that this one, this bit are same, only this bit and this bit is not equal, okay. So I can match this M0 with M8, okay, M0 with M8, okay. So that will be, so you can see that this one and this one is changing, 0 and 1 is there, so you have to put the underscore here, okay. Other bits are same, 0 0 0 0 0 0 0 0, okay, okay, okay. Now I have group, I have checked, I have matched the 0 group with the first group, so I have completed this matching, okay. I have completed, okay. And please remember, please keep remember that if you can match anything, okay, you can put the stick. If this one terms is matched with another terms, you can just put the tick, okay. You should put the tick, okay. So this is also very important. So this one and this one match, so I can put this and this two, and this one and this one also match, so I can put the tick here also, okay. If it is matching anyway, okay, you can put a tick, okay. If at least match with one terms match with one terms, you have to put the tick, okay. Okay, so now we will move to the next one, okay. We are still in step 4. We are still in step 4. We are matching, okay. In step 4 we are matching, okay. Now we match the first group with the second group, the first group with the second group, okay, okay. So here you can see that you have 4 variables, there are 4 groups, okay. So you have to map this term with this one, and this term with this one, this term with this one, okay, and this term with this one. So you have to you have to check 4 conditions. This one with this 2 and this one with these 2. Okay, so I try to match. Okay, so I first try M1 with M3, M1 with M3. Okay, so you have 0 0 0 1, M3 you have 0 0 1 0. Here you have 0 0 0 1. Okay, and M3 you have 0 0 0 0 1 0. Is this match or not? Can anyone tell me? Is this match or not? Please tell me. Is this matched or not? No, I think it is not a correct answer. Okay, so please check this. Yes, and 3 is yes. Yeah, I have done a mistake. Okay, M3 is 0 0 1 1. Okay, M3 is 0 0 1 1. Okay, M0 is 0 0 1 1. So I think your answer is correct. Okay, actually that can match. Okay, yes, it can match. Okay, because M1, now I am going to check M1 with M3. Okay, M1 is 0 0 1 0 0 0 1. M3 is 0 0 1 1 0 0 1 1. So you can see that this bit, and this bit, the 4 bits are same, but this bit only change. 0 and 0 1 change. Okay, so I can map this. Okay, I can map this. Okay, so that will be my first group. Okay, so M1 and M3 is matched. M1 and M3 is matched. So what is the value? 0 0 underscore 1. Okay, 0 0 underscore 1. Okay, so now I map M1 with M9. Okay, so M1 is 0 0 0 1, M9 is 1 0 0 1. Is this matched? Is this matched? Yes, it is matched. Okay, because this term, this one, and this one same. Only ones are changing. Only one position is changed. Okay, only one position is changed. So you have 0 and 1. Okay, so this is the uh, uh, the the mismatch variable. Others are matched. Okay, so you can match this M1 with M9. M1 with M9. You can match. Okay, so M1 with M9. So you will have this one is not matched. Others are okay. No? 0 0 1. Correct? Okay. So that is correct. Okay. Now I have mapped with this. Okay. So you can see that M1 is matched with M3. M1 is also matched with M9. So you can put the stick. Okay. Because it is matched. Okay. These are matched with others one. Okay. You can put the tick. But you can put the tick, but you can't go to the next matching, next group. Okay. Because here you have in this group, with the first and second group, you have to match this M8 with this M3 and this one with M9. Okay, so you can put the tick, but you have to map this. Okay, still you are not completed. Okay, so I will map M8 with M3. M8 is 1 0 0 0 and M3 is 0 0 1 1. These terms are matched or not? M8 and M3 matched or not? M8 and M3 matched or not? Yes, no, very good. Okay, it is not matched because, yes, not, okay, because you can see that you have two bit changing. No? This bit is changed, this position, bit position is changed in actually 3 bits there. Okay, so 3 bits are changing. Okay, so that means you can't map this. Okay, so M8 and M3 you can't match. Okay, so you can't write M3 and M8, but you have to put the tick because these are involved in matching. Okay, so you have to put, you have to keep the tick. Okay, now I match M8 with M9. Okay, so M8 I have 1 0 0, M9 I have 1 0 0 1. Okay, so you can see that this one okay, this one okay, this one okay, these are not okay. That means this also can match. Okay, M8, M9, okay, M8, M9 also can be matched. Okay, so you have 1 0 0, this one 0 and 1, so you have to put it underscore. Okay, correct. Okay, so now you have to match. Now you have matched the, now you have matched the second with third. Okay, now you have matched the second with third, and you have to check for status. Okay, so we will check one by one. First you have to match M3 with M7. Okay, M3 you have 0 0 1 1, and M7 you have 0 1 1 1 1 1 1. You can match, no? Because this one same, only one bit position are changing, so you can map it. Okay, so this will be your third group. Okay, so you can map M3 with M7. Okay, and you will have M3 with M7, so you will have 0 underscore 1 1. No? Okay, I hope this is correct. Okay, so if I am doing any mistake, you can ask me. Okay, and then we try to map M3 with M11. M3 with M11 is also matching, no? Because these are this one same, this one same, this one same. So this also match. Okay, and this one not change. So we have only one bit position. Okay. So I hope we can map M3 and M11 also. Okay. So you will have 0 1, that means dash, 0 1 1, 0 1 1. Correct. Okay. M3 and M11 also you can map 0 1 1. Okay. Okay. Now you can see that this M3 map with M7, so you can put the tick, and M3 map with M11, so you can put the tick. Okay, and but you can't complete this. You have to check this M9 with M7 and M11. Okay, so you have to match these two also. Okay, so if I match M9 with M11, okay, this is 1 1 same, 1 0 0 same, 0 1 not same, 1 1 same. No? So you can map. Okay, M9 with M11 you can map. No? M9 with M11 you can map. So you have 1 1. Okay, then you have 0, 0, then you have 0, 1, that bit position is changing, so you have to put underscore, and 1, 1, so that is 1. Okay, okay, so you have to map M9 with M11. Sorry, so you have mapped M9 with M. We have mapped M9 with M11, no? Okay, so it is mapped, and you have to map M9 with M7 also. M9 with M7. Okay. M9 with M7. So you can see that 1, 0 there, not match. 0, 1 there, not match. Oh, that means not matching, no? Okay. So if you consider M9 and M0, so you have 1, 0, 0, 0, 1. M7, you have 0, 1, 1, 1. Okay. Okay. So you can see that this not change, this is changing, this is changing. Only this one is same. So M7 and M3 cannot be matched. Okay. M7 and M3 cannot be matched. Okay. Only M9 and M3. So we right. Okay. We are correct. Okay. So now we have complete that one also. Okay. Now you have to. Okay. Are you okay with this? If you have any concern with this grouping, please tell me. If you didn't get the same answer, please let me know. Maybe my one may be incorrect. Okay. So if you got any wrong answer or any another answer, you can ask me. Okay. You can let me know. Then we can check it again. We can double check. Okay. Okay. So I'm going to do the next grouping. So that will be our final grouping. Okay. Okay. So we have to match the third with fourth. Okay. So we have 3, we have 2 variables, and in 50 we have only 1 variable. So you have to match it with this, and you have to match it with this also. Okay. So let's do the matching. Okay. So you can see that 1, 1, 1, 1, 1, 1 same, 0 and 1 change. Okay. So M7 and M15 can be mapped. Okay. M7 and M15 can be mapped. Only one bit change it. Okay. First bit change it. Others are same. 1, 1, 1. 1, 1, 1. Okay. So you can put the tick here. Okay. Because this is also involved in matching. Okay. But if you put the tick, it is not the N. You have to match M11 with M15. Okay. So if you match that, you can see that 1, 1 same, 0, 1 not same, 1 same, 1 same. No? So this also can map. Okay. This also can map. Okay. So we have M7, sorry, M11 and M15. No? M11 and M15. So you have 1, 1, 1. So here you have 0, 1, that is not map. And here you have 1, 1. Okay. So that is the matching of the fourth group. Okay. So we don't have any other one. So we can stop here. Okay. But this will not the end. Okay. Don't be happy. Okay. This will not the end. You have to do another step also, and the other steps are same. Okay. Other step are same. You have to do the same thing. Okay. You have to same thing until we reach until so we are doing this again and again. We will have one time that we can't match any of these groups with other ones. So at that time we should stop. Okay. So we have to continue this. Okay, you have to continue this. Okay, so can you do it by yourself? Okay, so you have to match. So this is the, so I will do this by myself quickly. Okay, otherwise we are running out of time. Okay. And here we are going to do the same thing. Okay, we are going to repeat this step. Okay, so you have to check the group with the next group, and you have to put the matched pair. Okay, so the same step. Okay, so here also I will write group. Okay, matched pair. Okay, matched pair, and then I will take some space here, more space here, and you have binary representation. Okay, binary representation. Okay, so now I am going to do the same thing. I am going to check n group with the n plus 1 group. Okay, some of it, you know, n group with the n plus 1 group. Okay, so here I'm going to match 0 group with the first group. Okay, so here you have some matching, 4 matching step. Okay, not step actually, 4 matching events. Okay, so you have to match this one with this one, and this one, and this one, and this one also you have to match with M1, M3, M1, M9, M8, M9. So you will have altogether six matching status, no? Okay, 6 matching status. Okay, so we will match. Okay, so first I use this one and this one. So if you consider this one and this one, you can see that. So this is, we have to be careful here. Okay, because we can make mistake. Okay, so this is 0, 0 underscore with 0, 0, 0, 0 underscore 1. Okay, so can anyone tell, is this matched or not? Please give your answer. Is these two codes are matched or not? M0, M1 and M1, M3 matched or not? Please check the bit position. You maybe think this one, no? This underscore. If you don't have a same underscore, that also changing, no? That is not the same bits. Here you have 0 bits, and here you have underscore. So it's not the same bits. Okay, so there is a bit change. Okay, so is this matched or not? Please, someone give answer.
Not matched.
Sorry?
Not matched.
Yeah, not match. Very good. Because you can see that this bit position, this bit position are same, but you have two mismatched. Okay, so these are not matched. Okay, so in this one is not matched with this one. So we are not putting any tick. Okay, because it is not matched this thing. So I'm going to match this M1, M0, M1 with this one. Okay, with this one. So what is the thing? Okay, so you can see that 0, 0. This is also not matched, no? correct? This is also not matched because you can see that 0, this is changing. No, yeah, I write it here 0 0 0 underscore, and I'm going to match it with this one 0 0 1. Here you have 1, no? Is that so? It is here you should have 1, no? Yeah, 1. Okay. So this one and this one not matched now. Okay. So it is also not matched. Okay. And you have to check this one. Okay, you have to check this one with this one, with this one. Okay. So you have 0 0 0 underscore. This one you have 1 0 0 underscore. This is matched or not? Please tell me someone. This is matched or not? This one and this one matched or not? This one and this one matched or not?
No.
Yeah, it matched. No, thank you. Very good. Okay, it's matched because we have only one bit position change in, no? Okay, so you have the group 0. Okay, you have the group 0. Okay, and the matched pair is M0, M1, and M8, M9, no? M8, M9. Okay, so you can see that this one, this one, this one same. This is not same, no? So here you have to put underscore. So this one, this are same. So you have 0, 0, correct? Okay. So you have that one. Now you have to map. So you have mapped the first term with these terms. Now you have to map the second terms with the. Now you can put a tick here, no? Because it is mapped with someone. You can put a tick here and you can put a tick here. Okay, because it is already mapped. Okay. Now you have to check. Okay, you have to check this one with others. Okay, so let's check. Okay, so I'm going to check this one and this one. So you can see that here you have a bit changing, here you have a bit changing. So this one and this one not match. Okay, and I am going to check it with this. Okay, so you can see that this one same, this one same, this one same. Here not same. So it is matched now. This one and this one matched because you have minus 0 0 1. Okay, sorry, here you have minus 0 0 0. Okay, and here you have I delete this digit, no? In 1 and 3, what is the value? 1. Okay, so here 1. It is not matched, no? Am I right? It is not matched, no? So we are going to match this one with this one. So you have okay, no? Okay, it is not matched. Have I done any mistake here? So here you have, so we have done with this one, and we need to do this one. Okay, here M naught. Here you have. What is the, yeah. M not M8, no? M not M8, you have underscore 0, 0, 0. Okay. So here you have underscore 0, 0, 0. M1, M3, you have 0, 0, 0, 1. So it is not matched. Okay. So these are not matched. Okay. Correct. And I am going to check this with this one. Okay. I will take this again. Okay. Please excuse me. I think you are not, you are clear with this. Okay. So I will. Okay. This is very boring thing. Okay. But you have to do this. Okay. Okay. Now we are going to, we have done this matching. This one with these things we have already matched. Now we have to match these terms with these three. Okay. Now you have this one and this one. It is not matched because you have 3-bit position changing. Now you are matched this one with this one. I think that is matched, no? Okay, this one and this one matched. Okay, because you have minus zeros underscore 0, 0, 0. Here you have underscore 0, 0, 1. So it is matched, no? Okay, so this terms is mismatched. Okay, so it is matched. That means M0, M8, okay, M8, M1, M9. So that is matched. Okay, so you have underscore 0, 0. Again, you have underscore. Okay, so that will be a 0th group. Okay, no, we have to consider the other thing also. Okay, so we have matched this one with this one. Okay, so you can put a tick here and here, no? Okay, you can put the tick here, and also you can put the tick here and here because these are also matched. Okay, and we have matched this one with this one, this one with this one, and we have to match this one with this one. Okay, so you can get that this one not change, this one change. No, so it is not matched. Okay, so this one and this one not matched. Okay, because 2-bit position not changed. Okay, so we have to go to the next one. Okay, group 1. Okay, group 1. So that means you have to check the first group with the, so this is second, this is third. Okay, first group with the second group, first one with the second one. Okay, so you have to match this one with this one. Is it matching? 0, not matching. Okay, and this one with this one, is it matching? This one with this one, is it matching? This one and this one not matching. This one and this one, 0 not change. Here change, it is also not matching, no, because two position are changing. And this one and the last, this one. So I think it is matching, no, because you can see that in 1 and 3 you have this one 0, 0 underscore 1, and M9, M11 you have 1, 0, underscore 1. So you can see that these are same, only one dispersion change. Okay, so you can match it. Okay, so you can match M1, M3, M1, M3 with M9, M11. Okay, M9, M9, M11. Okay, so you have here the bit position change. So you have underscore here 0 underscore 0 0 then underscore again 1. Okay, correct. Okay, so I hope it is correct. Okay, so we will verify this. Okay, using a K-map, I think we can verify this easily. Okay, so we will go. Okay, I think you can get the idea. Okay, so maybe I am doing, if I am doing any simplification mistake for this 1 and 0 interchange, don't take it too serious. Okay, follow up the procedure. Okay. Okay, so if you have any lectures, you can leave, but I will continue this up to end and I will upload. Okay, so if anyone has a lecture, you can leave, no issue. Okay, so I will continue anyway. You can leave. So, so before leaving, if you have any problem, please ask. Okay, up to this level, do you have any problem? Do you have any issue? Unclear points? Okay, so I hope you don't have. Okay, so if you have, you can ask. Okay, okay. So next go to the mapping again. So I have map. We are mapping the first one and with the second one. So we have already mapped this one with all three, and we map this one also with all three. Okay, and we have to map this one. No? We have to map this one. So M8. So you have 1, 0, 0. You have to map with this one. So you can see that the position are changing. So you can't map. Okay. This is no, we have to map this one. No? We have to map this one. Sorry. Before still we are not completing this one. Okay. So we come to this one. Okay. So you have to map this one with this one. Okay. I think that is not mapping because the bit position are changing. Okay, and this one I'm going to map with this one. Okay, same, changing, same. So I think this also can get, no, we can map this and this one. Okay, yeah. Okay, so if I get this one, you have 0, 0, 1. Okay, and if you consider M3 and M11, you have 0, 1, 1. Okay, so you can see that these are same, only this position is changing and this one also same. Okay, so we can map that one also. Okay, so you can map M1, M9 with M3, M11, no? M3, M11. Okay, So you will get underscore 0, and here you change the bit position again underscore, so underscore 0 underscore, and you will have 1 here. Okay. Okay. And now you have to map this one with this one, third one. So you can see that this one and this one. So you can see that this one and this one already mapped. Okay. This one and this one already mapped. Okay. And also this also mapped, no? Because M8, M9 also mapped, no? Okay. So you can put the tick here also. Okay. So here, or you can put the tick because it is involving in mapping with at least one term. Okay. So you can put the you can put the tick. Okay. So that tick also very important. Okay, I will tell you why. Okay. So next we have to map this last term with others. Okay. So you can see that this is not matched because this one changing, this one changing. And if you consider this one and this one, it is also not matched because this one change, only this position same, but others are again changed. Okay. And if you consider this one, it is matched, no? This one same, this one same. No, it is not matched. This is and this one not same. This one and this one also not same. So it is not matched. Okay. So we have to uh, go to the other group, next group. That is, we need to group. Okay. We need to group second with the third group. Okay. Second with the third group. Okay. So we will match again. So we have to match again 6 status. No, here you have to match 9 status. Here you have to match 6 status. Okay. So while this is doing, you can feel that Boolean algebra method and the K-map method is very easy. Are very easy. Okay. Actually, that is true for only few variables. But if you have much variables, around 8, 9, 10, 11, such variables, this method will be easy. Okay. And the other advantage that you can implement this in MATLAB or Python like language. Okay. So you no need to do this manually. Okay. Once you input your expression, you can get the simplified output very easily. Okay. So that is the biggest advantage, I hope. Okay. So so I'm going to map these things again. Okay. So M3, M7 with these two not matched because you can see that 2 bits are changed, and M3, M7 with others, it is also not matched. Only the last bit are mapped. Okay, so 2 bit position are changing. Okay, now I come to the M3, M11. Okay, so it look like match, no? This one and this one. See, dash dash 0 1. It is not matched. 1 1 1 1. So only one bit position is mismatched. So we can match that. Okay. So you can match M3, M11 with M7, M5. M7 with M5. Okay. M3, M7, M3, M5. Okay. So M15. Oh, yes. M15. I'm sorry. M15. Okay, M15. Thank you. Okay, so M3, M11, this one and this one. So you have underscore underscore and so this one. So this one with this one. No? So this underscore, okay, and 0, 1 again underscore 1, 1 same 1, 1 same. So I can put 1, 1. Okay. So you can put the tick here, and also you can put the tick here, and also you can put the tick here also. Okay. Now you have to map this one with this one. Not same mapping. No? This one changing, this one changing. So 2-bit version are changed. So this one and this one not match. Okay. So we have to consider the final one. Okay. So you have to match this one with this one, no matched. Okay. 1 dash 0 1 not matched. And this one, this one, this one, which this one, this one with this one. Okay. And I think it is mapped. It look like map, no? Because 1 0 0 1 0 dash 1 1 dash, no, it is not map, no? So that is all, no? Okay. So that is the all. Okay. I think that is okay. Have I done any mistake? Okay. So here M3 we have match M3, M7, M11. Thank you. Okay, another one is matching, no? M3, M7, M3, M7, M11, M50. Let's see. M3, M7, 0, 0 dash 1, 1. Okay. 0 dash 1, 1. And M11, M15. 1, 1. Yeah, it is matching. No, yeah, it is matching because these two only changing. Okay, we have missed that one. No? Okay. Yeah, M3, M7. Yeah, M3, M7, M11, M15. No? Okay. This one and this one. No? Okay, I get that one. M3 0 dash 1 1. This one 1 dash 1 1. Okay, so it is matched. Okay, so you are correct. Okay, so before that one we have another mapping M3 M7 M3 M7 M11 M50. That is correct. And also you have underscore. Okay, another underscore and 1 1. Okay, so we have do the next grouping also. Okay, so can you check, can you try to do the next group also? Okay. Can you try to do the next grouping, the next matching as we have done just now? Okay, so we have this table. Okay, now this one also should match, no? Until, so there is a one when we are going when we are following this step. Okay, so you will get one time we can't match any terms. Okay, at that time you have to stop. Okay, so can you try to match this one also? Okay. Actually, I already simplify this using K-maps. Okay, so I think okay, can you check this? Can you check this? I hope this will we can't simplify this. We can't do the grouping anymore. Okay, but anyway, please try. Give 5 minutes or 10 minutes and try. I will give 5 minutes, 5 minutes or 10 minutes. You can try. So here you can see that this one you can't. Okay, because 2-bit person are changed. This one you can't. Okay, and this one you can't, and this one also you can't. No, yeah. So we can't do that one. Okay, so you have to still. Yeah, yeah, I hope so. We cannot match anymore. Okay, because I already solved this using the K-map. Okay, so I have the answer. Okay, so you can't match this one with group 2, group 0 with group 1. Let's check group 1 with group 2. Okay, let's see. So if you try to match this one with this one, you can't match because no big question are changing. This one with this one you can't. This one with this one you can't, and this one with this one you can't. Okay, so this is the end. Okay, now you can be happy. Okay, because we have done that repeating steps. Okay, so the next step is we have to write the expression for these terms. Okay, so you can see that this is a group. Okay, and this is also a group, and this is also a group. Okay, so you have to write the expression for each of this group. Okay, so what is the expression here? So you already know that this is A, B, C, D. Okay, A, B, C, D. Okay, and if you have this underscore, that means there is no any terms there. Okay, so there is no A and B terms, only B and C terms are there, but you have 0. That means you have the complement, no? B bar, C bar here. Okay, and what is for this one? What is the expression for this one? Please someone tell. Okay, what is this one? A and C are not available, only B and D are there. Yes. Okay. Yes, only B and D are there. And here B bar, B. In the same manner, here you have A and B not there, C, D. Okay. So you have 3 ones. Okay. So this is somewhat simplified, but not all. Okay, we have another step also. Okay, so these are called, as I can remember, implicant. No? These are called implicant or something. This is a prime implicant, I think. These are prime implicants. Okay, these are prime implicants. But sometimes we no need all these prime implicants. Okay, we can eliminate one or two implements. Okay, so you have to check the necessary prime implements. Okay, the essential prime implements. Okay, now our next step is that is the fifth step. No, so you have to repeat the fourth step up to this level. Okay, then you have to go to the next step, fifth step. Okay, there you are going to find the essential means needed, requirement. Okay, අත්‍යවශ්‍ය, essential. No, I think the essential is the word. Okay, essential prime implement. Okay, you have to find the essential prime implements. Okay, because these terms also you can eliminate sometime. Actually, you can see, no, if you see this, you can eliminate some terms here using the algebra. Okay, but we are not going to use the algebra. Okay, you have to use this method. Okay, so you can see that. Okay, so now also we have to make a table. Okay, we have to make a table. Please refer that. I think it is called the implicant table or prime implicant table. Okay, let's say it is prime implicant table. Okay, so here you have to put the implicants here: B bar, C bar, B bar, D, C, D. Okay, B bar, C bar, B bar, D, C, D. B bar, C bar, B bar, D, C, D. Those are the prime implicants. Okay. Okay. And then, okay, then, okay, then you have to consider all the mentums. Okay, so we have 8 mentums. No, we have 8 terms. We have eight terms: M0, M1. Likewise, these are the no? This one. So we have 8 terms. No, 1, 2, 3, 4, 5, 6, 7, 8. Okay. So you have these terms: M0, M1. Okay, I will write it here somewhere. M0, M1, M3, M7, M8, M9, M11, M15. Okay. So so we have to write all these implements. The binary representation actually. Okay. So if you write all the terms here, it will be okay. Okay. But I will write only the implements. Okay, that is M0, M1, M3, M7, M8, M9, M11, M50. Okay, so you have these momentums. Okay, 1, 2, 3, 4, 5, 6, 7, 8. Okay, now you have to mark the involved involved mentums. Okay, all the involved mentums for this prime implicant. Okay, for example, if you check this B and C. Okay, actually that is one advantage of writing this implicants. Okay, this mentums. Okay, right. writing this main terms is here you can get the advantage. Okay, so you can see that here you have b bar c bar. For that expression only m0, m1, m8, m9. Okay, so those are involved, no? M0, M1, M8, M9, M0, M8, M9. Okay, so these only these four uh, main terms are involved for B bar and C bar. So you have to mark it here. Okay, you have to mark it here. So you have this main terms, okay, and you have this main terms, and you have 8, no, M0, M1, M8, M9, okay, M8, M9, and you have this momentums and this momentums, okay, this momentums and this momentum. Okay, in the same manner, can you tell me what is the momentums involved in this expression B bar D? Okay, so look at this one, B bar D. What are the momentums involved for this B bar D? M1, M3, M9, M11, no? M1, M3, M9, M11. 1, 3, 9, 11 involved, no? Okay, so you have 1, 3, 9, 11, correct? Okay, in the same manner, can you check what are the momentums involved in C and D? C and D. What are the momentums? Just tell me the value. 3, 7, 11, and 15. No? Okay, 3, 7, 11, and 15. So you have 3, 7, 11, and 15. Okay, okay. So we have marked all the involved momentums for these prime implicant. One thing I forgot to tell, when you find the prime implicant, okay, when you find the prime implicant, you have to check again this table. Okay, so if you haven't put a tick, okay, in every table, if in any table, if you haven't put a tick, okay, so you have to take that one also as a prime implicant. Okay, so that one also you have to get as a prime implicant. Can you understand? For example, if you don't have a tick here, okay, if you don't have a tick here, that means this term is not matched with anyone. Okay, not matched with anyone. So you have to get this as a prime implicant. So here it will be A bar, B bar, C bar, D bar. Okay, so this also should be considered as a prime implicant. But in our case, you can see that in every table we have tick. No, every table, in every table, any terms matched with at least one terms. Okay, so that is why I told you that the tick is very important. Okay, do you understand that one? Did you understand that? If you have any problem, please ask. Okay, so again go through this example. Okay, if you have any doubts, okay, then you can ask me. Okay, you can mail me if you have any problems. Okay, if any unclear points, you can send me a mail, then I will try to explain it again. Okay, so now in this case we have put all the ticks in our tables. Okay, I can't remember the name for these tables. Okay, okay, so we don't have any other prime implicants. Okay, so we have only these three prime implicants. Okay, so what you have to do is you have to consider only prime implicants with one cross, only one cross. Okay, so you have only one cross here. Okay, here you have two cross, here you have two cross, and here you have only one cross here. Okay, and again you have one cross here. Okay, so you have to consider the prime implicant with only one cross. If you have a if this column has one cross, okay, you have to consider that that complement also, that implicant only. Okay, did you get that? Okay, so you can see that here you have one cross. Okay, so you have to consider this complement, that is b bar c. Okay, here this so you can see that here you have two cross, here you have two cross. Okay, and here also you have two cross, here also you have two cross, so you can eliminate this implicant. Okay, M8. I couldn't understand. M8 has one cross? No, M8 is already matched, no? You means this one, we have matched with, for example, you can see here, no? Because M8 is involved here, so it is matched anywhere. So you don't have a cross. You are talking about this this one, no? Yeah. M8 you have one cross. Yeah, you are correct. Okay, you have one cross, but that one cross is related to again B and C bar, B bar and C bar. Okay, so you can check, you can take only B bar and C bar. Okay, and if you consider this one, you can see that here you have one cross and here you have one cross. Okay, so you have consider only this one. Okay, so that is CD. Okay, so it will be plus CD. So this will be your simplified version. Okay, so F is equal to B bar C bar plus C. So this will be your answer. Okay, so actually this answer is correct. Okay, I already have verified using K-maps. Okay, so I think you have learned the K-maps in your previous sessions, previous modules. So you can try to get this answer as a homework using the K-maps also. Okay, so it is very easy actually. Okay, so can you try? Did you understand this procedure, our algorithm, QM tabular method? Did you have an idea? So, I hope you can go through this lecture again. Okay, so okay, no, you got it, no? Okay, thank you. Okay, maybe all students may not this algorithm clearly. Okay, so I ask you to go through this example again. Okay, and try to clear all the points. Okay, try to get clear all the points, and if you have any problem you can ask me. Okay, then as a homework, okay, you can do the example by yourself. Okay, uh, don't refer the book. Okay, so try to do this example by yourself. Okay, Okay, so this is the example. I think, yeah, this one. This one is the example. Okay. So can you try this example by yourself? Okay. And you can verify it with the answer. Okay. So here you can see that the mentums are not indicated here. In these tables, mentums are not indicated. It is not a must. Okay. To to uh, to mention the mentums is not a must, but you can put it. Okay, you can put it. Then this prime implicant table you can get very easily. Okay, yeah, this is called prime implicant recorded. No, that is prime implicant table. I think I am right. Okay. So this prime implicant table you can get very quickly if you put the mentums also, mentums number also. Okay. So please try to do this as a homework, that example as a homework. So if you need, I will discuss it again in the next one. Okay. And in this example, we have done sum of product. Okay, sum of a sum of products. Okay, and also we have to do one example with product of sums. Okay, so we will do it in next lecture or next session. Okay. Okay, so anyway, thank you for being with me. Okay, so okay, thank you very much.
Thank you, sir.
Okay. So let's